and from there infer what would be then the temperature that you should be getting. So this is not possible because it is not an analogous state, it is a different state now. So different parameters are influencing, and so we can not draw very firm conclusions on the development from the observation of previous carbon dioxide contents in the atmosphere. For instance, whether it would be stable, if you would get runoff effects, like from now we could have melting of permafrost soil in the north. Methane would be released, and that would change the greenhouse effect again, or the polar ice caps would melt. So all these things just do not repeat in the same way as we had it if they did melt in the past of the Earth, because it is not only depending on the carbon dioxide content, but also on these other parameters. And if they are different, like inclination of Earth axis to the orbit's plane, then there's a different correlation then, and then we cannot draw conclusions on stability of climate or instability from old data. That's just a different situation.
When we read the old data, one thing that is interesting, could you explain this, what it means, the net effect of human activities since 1759 in terms of anthropogenic warming and cooling influences on the climate?
Yeah, so old data in this sense means data on very old times. So times millions of or hundred thousands of years ago. Now, when we talk about the present climate change, that is what your question now is driving at, then we know that the Earth's temperature since the beginning of the 20th century, so since about the last 100 years, has been growing now by about 0.8 or 0.9 centigrades. So we have gone up already by almost 1 degree, and the speed of temperature to change is growing. So we have already 1 centigrade more than it was over long periods before, and we may get during this century not just 1 degree, but maybe 4 or 5 degrees of temperature rise.
Which will have quite large consequences for the planet.
Yes.
But apart from the climate change, much of the research shows that we are experiencing the Earth's carrying capacity crisis. Could you describe the concept of the human footprint? What is the state we are in now and will be by 2050 if nothing will change?
Yes. So you mentioned the term footprint. And the term footprint means, human footprint means the following: how many square meters of Earth does a person need for its demands to the Earth? So for food, for energy services, and also for the reabsorption of carbon dioxide. So how much space is a single person using from Earth? And this so average capacity of 1 square meter, by averaging polar and our regions and equatorial regions, also tropical regions, one can define an average square meter of Earth on Earth, and then how many such average square meters does a person need, and how does this relate to the available area or surface of Earth? And it turned out that in about 1980 there was the crossover, so when it was about 5 million people. So the Earth's carrying capacity was at best for 5 million people. And the prediction is that this capacity, actually, the carrying capacity, is not constant, but will go down as a result of climate change. Because climate change reduces agriculture, so food production will not function anymore in the same way as it did, where the plants have been optimized for. So we need new plants, which will take many decades before they have been developed or grown or selected. We use a lot of fertilizers right now, but the energy, the fertilizers are mainly made from oil. If the oil is too short or too expensive, we cannot afford having fertilizer. So many things will break down or go down, and then the carrying capacity of the Earth is going down. The largest single contribution to the human footprint to the Earth is the absorption